So the Galvin optimal mass formula defines the mass of baryons as this expression. Yeah, where m naught, a and b are simply the constants, and I represents the isospins and y represents the hypercharge, right? And if the mass of the hyperons is the same as that of sigma hyperons, then the correct options are, there are four options are given. So you have to basically, it's given the mass of the sigma hyperons is same as that of lambda hyperons, right? So then you have to find out the right option. So basically the two particles are here. One is lambda hyperons. So these are the main keynote things, and also the this is, you have to first note down the what are the things that are given, and using that how we can basically solve. I mean, there are some given conditions, right? Given equation, only given conditions, given equation. Using those only you have to solve the problem. So first we'll write down this to simplify the problem. This is the isospin, and minus one. Sorry, this is number 4 y square. Okay, fantastic. So good to go. Y is hypercharge and the mass is same. Another condition. Okay. So we need to know the isospin of sigma. These are the things we have to remember. Okay. Isospin of sigma is 1. And the formula of y is b by s. B is the baryon number. Baryon number is this strange number. Okay. The sigma hyperon is a baryon, so this is 1. The strange is -1, so it is 0. Now do the same thing for the lambda hyperons. Isospin is 0. Y is b plus. This is 0. 1 minus 1 is 0. Y, the value of the y is same for both the particles. Okay. But the isospin is different. For the sigma hyperons, it's 1. For the, yeah. But the thing is, mass will be same. If you carefully look into the problem, the mass has to be same. Y is also same, is 0. But only the isospin is changing, but you have to keep the mass same, having all this constraint, right? So it is not, so it's also not dependent on the I. That's what we are getting. So if it is dependent on the isospin, then probably the mass would have been different. But this is not the case. The mass is same for both the particles, right? So this is not dependent on, so M is not, yeah, dependent on the isospin, right? So it is depending on Y, because as the value of the Y is same for both the case, right? So M will depend for on depend son. M will depend on y only, and M is proportional to y, right? So there are four options. So in the four, actually it has written M does not depend on y, that you can see clearly see, does not depend on I, as even if the iso spin changes, the M doesn't change. Okay, so this is one of the correct answers, and second is M is proportional to y. Okay, so this is how you have to solve the problem. Okay, I'm done with the two problems now. Okay, yeah, bye.